Welcome to video 2, which focuses on chapter 2 of Big Ideas of Early Mathematics, Number Sense. The information in this video builds on the knowledge on creating sets, which was shared in video 1. The three key big ideas presented in this chapter of the book are that numbers are used in many ways, some more mathematical than others. Quantity is an attribute of a set of objects, and we use numbers to name specific quantities. The quantity of a small collection can be intuitively perceived without counting. In this video, we'll briefly review the definition and theory behind each of these ideas and then share implications and ideas for your teaching practices. When adults celebrate that young children can count to 10, 20, or even much higher, they typically mean that children can say the number word lists fluently and in order. This is indeed an impressive feat for a young child who hasn't been talking for very long. Nonetheless, the accomplishment does not mean that the child has developed a complete sense of number. Knowing the number words and understanding their numerical meanings are related but not identical accomplishments. In mathematics, number sense is defined in a variety of ways. In this video, we define it as the ability to understand the quantity of a set and the name associated with the quantity. Strong number sense developed in the early years is a key building block of learning math in the primary grades. That's because it connects counting to quantities, it solidifies and refines the understanding of more and less, and helps children estimate quantities and measurements. Numbers are everywhere in our life. Time, temperature, telephone number, social security number, money, and test scores name just a few locations where we find numbers. For this reason, a single numeral can mean different things in different situations. While 5 usually refers to that quantity, there are circumstances in which there is little, if any, quantitative meaning in the way it is used. For example, a baseball player wearing a jersey with the number 5 on the back. As children move through the world, much of their exposure to numbers will be in contexts in which they have little, if any, quantitative meaning, which can cause some confusion for children. For example, when you visit a classroom, we look at room number. This number is nominal or categorical, as it's used for identification only. When the hour hand on the clock points to 10 and children know it's free choice, the number 10 becomes referential. Numbers used as reference points are not inherently mathematical. In contrast to nominal or referential numbers, cardinal and ordinal numbers are building blocks for number sense and are essential for mathematical thinking. Cardinal numbers provide the answer to the question how many and how much. Understanding cardinality is a prerequisite to being able to meaningfully count or carry out number operations such as addition and subtraction. Ordinal numbers refer to positions in a sequence, such as first, second, third. When number words are used in this way, they do not indicate quantity. Instead, they function as a new kind of name that specifies rank or order. Children need many experiences and conversations to develop their understanding that when number words are used to name how many, the numbers act as attributes. Quantity is only one attribute of a set of objects. Young children whose basic number sense is still developing need more experiences with adjective form of numbers, in which numbers are used in context with the set they are describing, and not as a noun in which the numbers are drilled in rote exercises. Knowing this, be careful to always have children count something, rather than reciting the number words alone. All children are born with an innate ability to perceive the difference between one and two objects. With support and experience, they can quickly perceive and name how many for collections of 3, 4, and 5 objects. When a child looks at a small number of objects and knows how many without counting, they are subitizing. Doug Clements identified two kinds of subitizing: perceptual subitizing, which occurs when the numbers of items is 3 or less, and conceptual subitizing, which occurs when the numbers get a bit larger, such as 4, 5, 6. This occurs when children perceive sets of dots, such as the 6 on a dice is perceived as 2 threes. The time spent working on smaller quantities like 3 or 5 and not beyond 10 is meant to ensure that children's understanding for larger numbers develops from a strong foundation. Activities that take advantage of young children's innate subitizing skills and build their visual number sense will help them generalize their understanding that number names indicate a specific fixed quantity. Developmentally, it is critical to give children many experiences that represent numeric meaning in different ways. For example, counting out 5 cubes, drawing 5 circles, pairing the numeral 5 to represent quantity. Examples at circle time. The teacher beats the drum 5 times and asks how many. During snack, the teacher claps her hands 5 times to indicate how many goldfish crackers each child should have. On the playground, the teacher asks all children to jump 5 times before they are set free to run. Show a picture of 5 circles and ask them to bring back the same number of objects. Use fingers to sort 5 beans, matching finger to bean. Visual number sense builds on networks of sensory connections, enables children to picture and manipulate numbers in their head, and gives them strong reference for mathematical problem situations. Dot cards like dice and dominoes are engaging tools to build number sense. 5 frame and 10 frames encourage children to focus on spatial patterns for visual number sense by reinforcing those combinations of dots and empty spaces that add up to 5 and 10. Once children know the sequence of number words up to 10, it can be helpful to focus on developing their understanding of how many numbers relate to one another. Short number lines from 0 to 10 can really help children keep the sequence in mind. It is important that language, gestures, and a connection to a meaningful cardinal amount are integrated into these activities so that children become aware of the relationship between what they see and their conceptual understanding of the quantity. Remember, focus on small numbers such as 3 and 4 first, ensuring that children have ample opportunity to develop a true, meaningful, and robust understanding of these important building blocks. Some questions for you to consider when meeting within your PLCs. What do you think children gain by spending a long length of time working with small numbers? How can some of the activities shared in this video be part of your routine? Not just a one-time activity, but something that is returned to again and again.